So hopefully you have had time to watch the Pluto files and give you a little bit of a sense of scale for the distances of planets relative to each other. On the Pluto files, they use something different than a bowling ball for the mass of the Sun. It was a much bigger object, so the scale was larger for you. Since you did previously put guesses for size and mass, then we want to show you what those actuals would be today. So you had your guesses here. Some pretty fun guesses that I read through. If the Sun were a bowling ball, then Mercury is going to be about the size of a pinhead. Now, if you had anything similar to a pinhead size, you can just leave that here. This is just how I'll refer to things throughout the course, with the Sun being relative to shrunken down to a bowling ball. Venus is about the size of a peppercorn. Now, a peppercorn is what black pepper is before it is ground up, so peppercorn. Earth is very similar in size to Venus, so also a peppercorn. To help with the visualization of the size of a peppercorn, here's an assortment of peppercorns, so ground pepper before it's ground, compared to a US cent. Now, we did say that Venus and Earth are both peppercorn size. They're very, very similar in size. I've included this page 50 in your notebooks for those of us that want to know, okay, which one is exactly bigger or smaller as we go through this sense of scale. So we have Venus and Earth right here, and see either equatorial diameter for size. Venus and Earth, you'll see why they're both being represented by peppercorns. And of course, peppercorns different sizes. You have slightly bigger, slightly smaller relative to each other. Or you can think in terms of volume. And again, quite similar. When you take something as large as the Earth, or excuse me, the Sun, and reduce it all the way down to a bowling ball, this is why these things are so close in size on this very small scale when, again, the Sun is reduced to a bowling ball. Okay, back to our chart. Mars, if the Sun is the size of a bowling ball, is going to be about the size of a pinhead. Now, just like the peppercorns come in various sizes, you can look to page 50 in your notebook to see the exact difference and the difference between Mars and Mercury pinheads, Mars being a slightly bigger pinhead. Jupiter, which is indeed our largest planet in the solar system, probably the most common guess I see for Jupiter by students is basketball or softball. And it turns out that it is about the size of a shooter marble. So the marble that is the slightly larger one, the big marble in the bag of marbles. Saturn is about marble size. If you're not familiar with marbles, you can also think of this as bouncy ball size. Is there any in bouncy? Good question of the day. Bouncy ball for Jupiter. We have our planet Uranus, and it's about the size of a coffee bean, as is Neptune. Now, just like peppercorns come in different sizes, so do the coffee beans. So they'd be similar in size with coffee bean representation. Remember, if you shrink our enormous Sun down to the size of a bowling ball, these things do become similar in size. Page 50 is in that notebook to help us get straight which one in particular. Let's look at our mass guesses. This is looking at the Earth if it's 1 penny. If the Earth is 1 penny, we'll go down and then we'll work our way up. If the Earth is the size of, or excuse me, the mass of 1 penny, so it feels like a penny in your hand if you were to hold the whole Earth in your hand if the Sun were reduced to the size of a penny. Mars would be about 1/3 of a penny. Now remember, it's a federal offense to cut pennies, so don't cut your coins. Jupiter, if the Earth feels like a penny in your hand, Jupiter feels like 318 pennies. Saturn, 95 pennies. It was a little crazy because Jupiter and Saturn are fairly close in size as together compared to the rest. in a shoot 'em marble. So you would think that this mass would be a little bit larger. This is a fun little fact in your trivia mind. You can lock away that of all of our celestial bodies in our solar system, the one that is the least dense, so density, that's the symbol rho in Greek alphabet for density. Density is comparing an item's mass per its unit of volume. The mass of Saturn is quite small compared to its large volume. This gives the density of Saturn to be very low. When it comes to the property of density in the world of science, we love to compare if something will float or not in a medium, particularly water. Now, if you could find a bathtub large enough, fill it with water, and place Saturn inside, excuse me, that planet Saturn would actually float. Now, of course, when you took Saturn out and drained the water, it would leave a ring. Now, when your college professors, instructors, or planetarium narrators share that with you, you must laugh at that as though it's the most funny thing you've heard in all of your day. Any guesses at which planet you think is the most dense? Turns out Earth is the most dense of all the planets. The planet Uranus would be 15 cents in your hand if the Earth were 1 cent mass equivalent. Neptune would be 17 cents. Working our way up from Earth to the Sun, we have Venus being, no surprise, 1 cent. Mercury, about 1/3 of a cent. And again, refer to page 50 to see the exact which one is slightly more massive than the other. And the mass actual of the Sun, if the Earth's mass were reduced to 1 penny, would be 30,000 pennies. Massive, massive indeed. Let's finish off the chart by looking at the distance actuals if the Sun is a bowling ball with the mass of 30,000 pennies. Then the distances at which you would place these other actual items would be very disappointing to watch me fill out in a chart. This is one of the very big drawbacks of having this video format presentation for you. In the classroom, we would take you out in front of the school and pace out these actual distances, and it really is impactful because you get to see just how spread out things are. So just for the sake of you to have your bragging rights, that I know you put guesses in here and you might be curious, I'm going to put these numbers down here. And again, it's just very disappointing to just fill in the numbers and be on our day. We really would like to actually go out and pace these out to get a full sense of just how vast the solar system is. So for bragging rights, if you were to place a bowling ball at your starting point, and the bowling ball would have the mass of 30,000 pennies, that's what's awesome about the scale, is it all goes together. The bowling ball would feel like 30,000 pennies mass in your hand. So starting point of the bowling ball, we would then get on our pace crafts. I know, very punny. And we would walk 10 large steps. One pace is a very large step. And 10 paces away from our bowling ball, we'd place a little pinhead to represent Mercury. From Mercury to Venus would be 9 paces, and we'd place our peppercorn. From that peppercorn, we would place 7 paces away, peppercorn to represent Earth. And if we were outside, we would also have our eclipse glasses, and I'd have you don those and look up safely and see the sun. And then you would look back at the bowling ball marker that we had without the eclipse glasses, you could see it, and recognize that in the sky, the sun does indeed look about the size of that bowling ball from where we're standing at our peppercorn Earth. And then I would point out to you that on this peppercorn Earth, there are 7 billion humans. Well, 7.5 billion humans, I believe now is the count. And you are but one of those 7.5 billion humans. And if you think about a peppercorn hosting 7.5 billion humans, to represent how large we would be or how small we would be on that peppercorn, we would definitely be into subatomic particle sizes. And as you start to realize just how small we are, whether we be a human or we the planet or we the solar system is in the scope of the whole cosmos, you start to experience a human condition we call cosmic loneliness. There's nothing you can really do to escape cosmic loneliness. It's something everybody experiences as you start to relate to how large the universe is. So cosmic loneliness, something I will drive into your souls throughout this course. And then at the very end of the course, we'll put a little band-aid to help you with your cosmic loneliness. There is no cure, but we can give you a little band-aid. So looking from Earth to Mars, we would go 14 paces out to Mars, and we'd place a little pinhead. Now you might be looking from Earth perspective and say, well, Venus is closer to us than Mars. How come we're not doing a lot of exploration on Mars? On Venus, with Venus being closer than Mars. Well, we have done a fair amount of exploration of Venus. We initially thought because Venus was about the same size and mass as Earth, that the candidacy for life would be quite high. But we found out that the temperatures on Venus are staggeringly high, and that is the greenhouse effect. So the temperature is just very, 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 very excessive in terms of supporting life as we have come to understand what life is on Earth. And because the universe is so vast, we stick to a blueprint of how we know life developed on planet Earth, and we use that to think about life on other planets. Venus has clouds that contain sulfuric acid. So rather than water vapor clouds, they're sulfuric acid clouds. And we don't know of any life form on Earth that uses sulfuric acid as a solvent. Water is Earth's main solvent. To think about a solvent, a practical example I give is you have to do the dishes by hand. Like, oh, I'm just going to let these pans soak for a while. You're using it as a solvent. You spill something on a counter, the first thing we do is grab a wet towel or something, water, to try and clean that up. So sulfuric acid, just too intense for a life form that we know of on Earth that could use that as a solvent. Looking at Jupiter moving from Mars, now in between here we have the asteroid belt. In between Mars and Jupiter we have the asteroid belt. It's so far spread out and vast that we don't place a little marker and say here represents the asteroid belt, but be aware it is in between Mars and Jupiter. Jupiter on these paces from 14 out from Mars, 95 paces later would be Jupiter. And this is why we call these, oh, I shouldn't include the sun. This is why we call these the inner planets. And this becomes strikingly clear if you were to actually pace that out. And 95 more paces is where we begin with the outer planets. Jupiter to Saturn is 112 additional paces away from Jupiter. From Jupiter to Uranus, that is another 249 paces from Uranus, or from Saturn to Uranus, which is just mind-boggling that if we were to walk out and pace this and stand and try and see the tiny peppercorn Earth back here and think about one human being on that peppercorn with a telescope looking out and discovering Uranus, it's just outstanding to take that scale in. Then from Uranus to Neptune, that would be another 281 paces, and you truly get to grasp how incredibly large the solar system is and how far away these outer planets are. Now, many people often ask, well, how far away is Pluto, the dwarf planet? And at this time, we usually walk you to this point because you're actually off the school grounds. We'd have to have field permission slips to get you to be able to walk to Uranus. You're exhausted at this point anyway, so you're usually at this point going, oh yeah, we don't need to see all the planets, just tell us about the dwarf planet. All of a sudden you're not as emotionally charged by Pluto. But to get to Pluto from Neptune on this scale, Sun is a bowling ball, we would have to march out another 242 paces if you wanted to go to Pluto. Now, because with this chart, we do tend to go straight down and say Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, I don't want to leave you with the impression that Venus is our closest planet. Final bit of trivia from this chart is what I'll leave you with on this presentation, and that is to look at which planet is actually closest to Earth.
We normally think of it. So the minimum distance between the Earth and Venus is 24 million miles. If you have a look at this, this is how we generally think
very near, isn't it?
of it. Yeah, well, it is in sort of space terms. The minimum distance to Mars is 34 million miles, and to Mercury it's 48 million miles. So you would imagine that it all goes like that and everybody stays in the same lineup. However, that is not how orbits work. So let's have a look at this video, which explains it a little bit more. Initially, it looks as though Mercury is the furthest away, but the way the orbits function is that Venus often is right the other side of the Sun, making it really, really far away. And there's a guy called Oliver Hawkins, and he wrote some computer code to try and work this out. And he found that the planet that spends most of the time closer to Earth than any other is Mercury. So it's closest to Earth 46% of the time. Venus was closest 36% of the time, and Mars only 18%.